Hello 2P and welcome to your first lesson in the Polynomials unit. Our topic today is just a review of algebra concepts from grade 9, and our goal, I know how to collect like terms and apply the distributive law in algebraic expressions. So this is the section to get ready for polynomials, so we're going to review what we learned last year in case you have forgotten. So we're going to start off by talking about what a term is, and this is a term here, this 5x squared, and a term is made up of different parts. This is called a coefficient. It's the numeric part of a term, and then a term may have a variable attached to it. In this case we have an x, and then that variable has an exponent on it, making it an x squared. Now once we start getting more than one term hanging around our expression, we start to give them names. Like for instance, a monomial only has one term, and so a term and a monomial are kind of synonymous. Say I had 2x squared y, that would be a monomial. Now binomial, like bicycle, means two, so we have two terms. And how we can see one term different from another is they're separated by either an addition or subtraction sign. So I could have 2x squared plus 2x squared y plus 2x squared. Those are two different types of terms, and they're linked by that addition in the middle. Trinomial, like tricycle, means three. So three terms. So something like 4x squared minus 3x plus 7. That's something most of the trinomials we're going to be working with actually look like this. Now anything higher than 3 terms we just call a polynomial. These are all polynomials as well, but anything bigger than 3 terms, and we don't give it a special name. So polynomial, just anything greater than 3 terms, is just called a polynomial. So now we're going to start by working with some monomials, and we're just going to review our operations here. And you can see we have the rule out here, and I'm just going to show you how we get the rule. So starting with multiplying monomials, the rule is we multiply coefficients and add the exponents on the variables. And I just want to go over why that is, so that you can see where that rule comes from. So here we have these monomials. And what this actually means is that I have a 5 multiplied by an x, then I have a 3, and then I have 2 more x's. And I can multiply those in any order I want. So I'm going to choose to multiply the 5 and the 3 because I actually know how to do that. And then I'm going to put all the x's together, x times x times x. Well, the 5 and the 3 is easy. That's 15. And the 3 x's together I can change back into exponent notation as x cubed. And so I could have saved myself the hassle. I could have not done all of this thing here if I had just multiplied the 2 coefficients, 5 times the 3, and then saw that I had 1x here multiplied with 2 x's here, mean that I have 3 x's all multiplied together. So I just have to add up the coefficients. And remember, there's a coefficient of 1 on that x. Now, dividing monomials is very much the same. We divide the coefficients and subtract the exponents on the variables. So in this case, I'm going to write it out, same as I did before. I've got a 10 and 3 x's, and on the bottom I've got a 3 and 2 x's. So the 10 and the 3, I can't do anything with. It stays as 10/3, but this x and this x, they divide to 1 because anything divided by itself is 1. And this x divide to 1, and because anything divided by itself is 1. And so all I'm left over with is this 10/3 with an x attached to it. So I just write down 10/3 x. And I could have saved myself the hassle of not doing this stuff here if I just divided the coefficients and got my 10/3, and then saw that I had 3 on top and 2 on the bottom, So these two x's take out two of these x's, and I'm left with x to the exponent 1. So you just have to subtract the exponents. Now carrying on, we're going to do a little collecting like terms. Now like terms are things that have the same exponents and the same variables. Not the same coefficient, but the same exponents and the same variables. So up here I have this 5x squared, and it matches this negative 2x squared. And so I'm going to write those down side by side. I have a 5x squared, and I have a negative 2x squared. Then I have this plus 4x, and it matches with this plus 10x, and it also matches with this negative x. So I've got 14 positive x's, and then one negative x leaves me with 13 positive x's when I put them together. Okay. And now here I have a negative 3 and I have a positive 9, and when I put those together, and I can write them side by side, negative 3 plus 9. And notice that I put this one together in my head, but I haven't done it with these other two. You can put them all together in your head if you want to. You don't have to write them side by side, but if it helps you to write them all side by side, you could have even taken all of those here. Let me get my eraser here. We could have taken all of those x's and wrote them side by side to start with, so that I had a plus 4x, a plus 10x, and a minus x all written side by side, and then I have the minus 3 and the plus 9, so I write them all side by side there. Now I have to put them together. So those things that are the same, they have x squareds, we can put them together, and 5x squared and minus 2x squared gives us 3x squared. And these ones that are the same, we have 14 positive x's and one negative x. That gives us 13 positive x's. And of course the last group here, the negative 3 and the positive 9, we can put together, and that becomes positive 6. So you just have to group the stuff that have the same exponents and the same variables together, and then add or subtract their coefficients, whatever it is. And so let's just pull out that the instructions there. Add the coefficients on any term that has the same variables and the same exponents. And that should say on any term. So let's just scratch out thing there. Okay, now this distributive law. The distributive law says I have to take this 2x and multiply it through the brackets. So it's like having two multiplying monomial things here. I take the 2x and I times it by the x, so I now have 2x squared, because there are two x's multiplied together. And then I'm going to add 2x times 3. Well, 2 times 3 is 6, and that x has nothing to go with it, so it's just 6x. And our instructions here, multiply the monomial through the brackets. And that's all we do for the distributive property. Now, squaring something means to multiply it by itself. So, and this is the last thing we need to look at it, negative 2 squared means negative 2 times negative 2. And of course, when you have a negative times a negative, you get a positive. So the answer here is positive 4. Now, this is different than this because this squared is only on the 2, not on the negative. Last time with the use of the brackets, that squared was on the negative as well. So what this actually is just negative and then 2 times 2. Well, 2 times 2 is 4, and then there's just a negative out front, so the answer to this is negative 4. And lastly, what happens if we throw a variable in there? Well, this means 4x times 4x. So I can do 4 times 4 is 16, and x times x is x squared. And if you notice, that squared just applied to the 4 the same as it applied to the x, so we just squared 4, and then the x times the x is x squared. So be careful when you're squaring things. And that wraps up this lesson.